Okay, so let's take a look at question 3 on the review. And since you've got several questions, I may have to break this up into 2 videos or 3, but we'll see. Okay, so I'm going to write down that we've got our distribution for x already because we'll take that to another sheet. So our mean is 977 and our standard deviation is 216. And then our distribution for x bar, and sorry, my dog is making lovely noises in the background. And it's listed right after that, so I'm going to write that down. We want to know what is the probability that one randomly selected auto insurance is more than 1,007. Okay, so we want it to be greater than 1,007. So we want the probability that z is greater than 1,007, or really x is greater than 1,007. Okay. So first thing we're going to do, since it's only one, there's no sample size, we will use this information and use our z-score and this value in our z-score. Okay, so I'm going to go over to Word. I may have to pull up another page. All right, so I've pulled up the page, and I apologize, my Mew looks really funny just because my writing using my mouse is just bad. All right, but we want to take our value of x was 1,007. In our distribution, the mean was 977, and I apologize for this darn McAfee thing. I'm gonna have to look up how to make that thing just go away. And we're going to put that over the standard deviation that was 216. Now, as we do this calculation, let's make sure that we do the top first. We have to do that subtraction before we divide by 216. So if I put that into my calculator, that is 30 over 216. And let me see what 30 over 216 actually gives us. Okay, so no, it doesn't give us that. I cannot type apparently. Okay, 0.138888 repeating. So we'll just put 0.13. I'm just going to go out, say 5 decimal places there. We don't want to round off too early when finding these. So 5 or 6 decimal places is a good rule of thumb. Now, let's remember from a while ago that we were looking for the value being greater than 1,007. And when we look things up using either Excel or the standard normal table, it always gives us the probability that something is less than a value, not greater than a value. So if we want, anytime we want, greater, the probability of something being greater, what we have to do is subtract. Well, let's first. We're going to subtract what we get when we stick this value into our table from 1. But we do need to go ahead and put that in our table first. So I'm going to pop back over to Excel. I've been using it in another video, so I do have one open somewhere. Here we go. And gosh darn it, I forgot to write the value down before we popped over here. So let me go back again. Where are you hiding? Too many windows. Okay, so it was 0.13889. So let me go back over to Excel again. And we're going to type equal norm.s.dist. And our z value is 0.13889. And we want to put true. And so it gives us a probability of 0.555231. All right, now that is the probability that we get something less than 1,007. So it's very important, since it's less than, we actually need greater than. Anytime we need greater than, we're just going to subtract the probability we get here from 1. Remember, 1 is the total for the entire normal curve. Okay, so subtract 0.555231 from 1, and that is our answer to that problem. So let's see what that is. 1 minus 0.555231 is 0.44769, and this is the probability that we will put in our box in my open math. So we find our z-score, we put it into Excel, we get the probability, but when it's greater than, we have to subtract it from 1. If it's less than, if we're looking for the probability that we were less than 1007, we would have been done with this number right here. Okay, now let's pop back to the second part of that question. So okay, so a simple random sample of 39 auto insurance policies. We want to find the probability that the average cost is more than 1,007. Now we're going to do almost the same thing, but we are going to use, because we have that sample of 39 that was mentioned up above, we have to use the sampling distribution, this one here. So we're still going to use the z-score, but we have to use this new standard deviation. So I'm going to do the exact same thing that I did last time, but I'm going to do it with this as my sigma in the bottom. All right, so let me write down. Oh, well, it's really the same info, just we've got that random sample. So let's go back over here to my sheet. And now, though, I'm still going to use the 1007 for x. And I apologize that I'm so slow writing with this mouse. Actually, I should try my finger. And then we're still going to use 977. That's still our mean. That hasn't changed. But our standard deviation on the bottom is now 34.5877. So we will still get 30 on the top. We're going to divide that by 34.5877. And that's going to give us our z-score. And I think I need to go out of this to actually move this up. Let's see if it'll let me. Well, it moved up just more than I want. There we go. So let me see. What 30 divided by 34.5877 is? It is point. 0.86736. Now this is what we're going to put into Excel. I'm going to write it down so I don't have to look back at this sheet. And then let's remember that again, it was asking for greater than. It was asking for the probability that we got more than 107, or rather 1,007. So we've got to, after we get the probability out of Excel, we're going to have to subtract it from 1. But let's go and find our Excel again. Here it is. And I'm going to put in equal norm.s, dist. This time it was 0.86736, true. And it gives me my probability is 0.807128. Now that's the probability that we get less than 1007. And so let's get greater than by subtracting from 1. So I will now subtract 1 minus 0.807128. Okay, so let's see what that is. 1 minus 0.807128, and we get that our actual probability is 0.192872. And hopefully that will help with that problem. I think there was an E just asking about normality. So let's go back for a second. Look at that one. So E, do we have to have normality in order to do problem D? Now let's remember that as long as the sample size is bigger than 30, it doesn't have to be a normal distribution. So in this case, this sample was 39 auto insurance policies. So that's bigger than 30. So we do not have to have a normal distribution. If it's less than 30, we definitely have to have it tell us that it's normally distributed. Now, it told us anyway, but of course, in this particular instance, to do D, we did not have to have it. All right, so let's see. My video is getting kind of long, so I'm gonna stop. I have like a 15-minute limit, so I'm gonna stop that one, and then I'll let that one render while I do another.